Our next organic group or functional group are going to be the alcohols, and they're given the general formula of ROH. And that doesn't actually mean a lot to us until we know what an R group is. So this thing here. An R group is any carbon chain or any carbon group, so carbon containing group. So for example, it might be CH3, OH, CH3, CH2, OH for example. This OH group is quite special, and it means that the alcohols have got some very different properties to the hydrocarbons that we've already met and some other organic compounds that we're going to meet later in the unit. Because oxygen is such an electronegative element, and it is bound in this case to hydrogen, then this hydrogen here has the ability to form a thing called a hydrogen bond with a neighbouring oxygen of a neighbouring alcohol. So in this case we're looking at methanol, and methanol is liquid at room temperature, but it's actually a very small molecule. It's got a very similar molar mass to ethane and ethene, which are both gases at room temperature. Well, this hydrogen bond here is the reason for it being a liquid at room temperature, which is a particularly high melting point. You would expect it to have already boiled at room temperature because it's small molar mass, and because it's a molecule it would only have intermolecular forces between them. However, this hydrogen bond is a particularly strong intermolecular force. It's a special one, and it's not unique to alcohols. Carboxylic acids have them as well, but because of this hydrogen bond we have a boiling point much higher than you'd expect, so that's why this is a liquid at room temperature. It also melts at a higher temperature than we would expect for its molar mass. The smaller, so 1 and 2 carbon chain alcohols, so methanol and ethanol, are very, very miscible in water. And the reason is that this hydrogen bond does allow it, so if you could imagine this not being a methanol molecule being H2O, which has a similar shape, it can hydrogen bond with water. So this means that most alcohols are miscible in water. However, that miscibility or solubility in water decreases as this carbon chain gets bigger and bigger. And the reason for that is that it's basically becoming a less polar molecule for a start, but also this non-polar or hydrophobic end to the molecule is starting to become more and more important as there's more and more carbons in there. Non-polar things will not dissolve in water, so only this end has the ability to dissolve in water, but if the hydrophobic or carbon chain end is really large, then it's much less soluble. And you see basically that the solubility in water or miscibility drops off quite dramatically once we have 3 or more carbons here. So basically propanol and butanol are both relatively soluble. Beyond that you tend to see 2 layers or a bit of a murky sort of look there. So our new functional group is the OH on a carbon chain or a carbon containing group, and these are called the alcohols. Because of the OH, oxygen being very electronegative and bound to a hydrogen, then a thing called hydrogen bonding can happen between neighbouring molecules or between molecules in water. This is a particularly strong intermolecular force, so it allows for higher than expected miscibility or solubility in water and higher than expected melting and boiling points.